Let me show a demo on changing fragmentation strategy of a large table with minimal downtime to applications. For this demo, we will be using the uh, loopback replication functionality within Informix Enterprise Replication. This functionality we released in 12.10x11. The loopback replication allows you to replicate data uh, from one table to another table within the same instance. The source and target tables can be within the same database or in two different databases within the same server. So for this demo, we'll be using the Docker. So I have a Docker scripts here. I did upload these scripts to the GitHub. I'll show you a link to the GitHub shortly. So let me set up the Docker. Let me build the Docker image and set up the container for this demo. Okay, the container is ready. We already logged into the Docker container. So let me log in from this terminal as well. So I am root, and let me change it to Informix user. Do have server up and running. First, I'm going to set up enterprise replication on this server. So we have enterprise replication up and running. So let me show you the schema for this demo. So we have this. First, we will create a DB space of 2 gig size using the storage pool. We create the database YCSB database, and we create one table you call user table. So now you have the user table ready to go. And first, let me insert 100,000 rows. So I have this parallel IUD, the SQL executable. I'm going to create 10 threads, each inserting 10,000 rows, and we saying the insert operation. So at the end of this, we'll have 100,000 rows inserted into the user table. So we can verify table info. So you can see that we have 100,000 rows. So let me simulate a live application. I'm going to use the same executable. This time I'm going to start 5 threads, each making 100,000 operations with a mixed. I'm saying that use a mixed operations. This includes insert, updates, deletes, and selects. Let me start it in the background. So we have these 5 applications actively working on that user table. Now our job is to fragment this table with minimal downtime to this application. So let me show you a new schema. This is my new schema. I'm connecting to the same database, YCSB, and I'm creating a table called user table underscore new. The only difference is that now we are fragmenting this table. So we'll create 3 DB spaces, each with 1 gig space, and create this new table. So by the way, we are creating the raw table to make it to load the data faster. If you have a secondary servers configured, you probably cannot use the raw table. You may have to create the standard table. So we have this new table created. Now let me load data into this new table from the uh, production table. So the user table is our old table. So let me initially load data from the user table to this new table. So remember that the applications are still actively making changes to the user table. So we did load 101,000 rows. Now let me change this table from raw table to the standard table and add the primary key constraint. So we have the new table ready to go, but the applications are still making changes to our old schema. So now let me define a loopback replication. So we have the local enterprise replication defined on this local node. Now let's go ahead and set up a loopback replication. So for that I need to modify the SQL host file and add a new group for the loopback replication. The way loopback replication works is that you need to define another ER server, but on the same server for the same instance. So I'm calling this, so I need to define a new group, calling this G underscore LB loopback, and I need to specify unique ID for the group. And for the service, I'm calling it as loopback. We have same host name, and I'm going to change the port number and change the group name to G underscore LB. Now SQL host file is ready to go. So now let me modify the onConfig file as well. So let me add the loopback service here. So make sure that the primary group always be first, then the loopback. If you have the primary group and loopback needs to be defined within the for the same Davis server aliases. So loopback, so primary Informix service, like say in this case Informix, should come appear before loopback. Now let me start the listener thread for this loopback connection. So I'll use the onboard -p command. So we have the listener ready to go. Now let's define loopback server. I'm going to use the cdr define server, sync with my primary group, and g underscore lb is my loop pseudo group. We did define ER. So cdr list server will show two ER nodes, but we know that g underscore lb is a pseudo server. Look at our magic cat servers. So there's two nodes. This is my primary group, and this is my pseudo group for the loopback connection. Here you can see that is pseudo attribute is set to true. So then we know that this is a pseudo ER server. Now let's define a replicate between the user table and user table underscore new. And this way we start replicating data from old table to the new table. So if you see this replicate definition is a standard replicate definition, and the difference is that we have to define we only support always apply config true. We don't support the update anywhere, so either you have to use always apply and or ignore. So the always apply is better than ignore. So I'm using the always apply config tool, and I'm replicating from YCSB database. This is my primary group and user table. To I'm selecting everything. To the target instance, I am saying that same database, and this time I am specifying the loopback pseudo group, and I'm specifying the new table now. So we only support the primary and target replication. So we don't support the update anywhere configuration with the loopback replication. So we did define the replicate. Now if you look at the replicate definition, the options field now show that loopback attribute. That means the enterprise replication recognize that this replicate is defined for tables between in the same instance. So let me start this replicate. Now you can see the data starts flowing between from source to the target. In this case, the same server. You can see that it started replicating data. Now, since the applications are actively running, and there's a gap between when we define the replicate and when applications are started running. So there will be, so at time t1 we did load the data, and at time t2 uh, we defined the replicate and started the replicate, uh, started replicating data. So whatever the changes happened between time t1 and time t2 will not be there on this in this new table. So we will use the data resynchronization task to repair the data. Oh, by the way, one more thing. So if you are using the loopback replication, I would recommend setting this config parameter CDS suppress ATS so RIS1 to ignore this warning ATS and RIS files. For example, if you are replicating an update, if there is no corresponding insert, the enterprise application automatically convert update to an insert. And same thing if you are replicating delete, if there is no row on the target, so delete will be ignored. So we don't want ER to generate those ATS and RIS files. So let's ignore that. Now let's do a repair. So I'm going to running this CDS check repl, replicate name. This is my replicate name. This is my source node. This is my primary group. This minus A is all. We are repairing data between all servers. In this case, between primary group and the pseudo group. And we are naming the job and we are specifying the repair option. Let's monitor the status of this job. Repair task should be done any moment now. Remember that we are doing the repair operation while applications are still actively running. So the repair task is complete now. Now the data is in sync between source and target table. So we can stop the application. I'm going to kill the application, and then we need to wait for all the queues to drain. I'm going to run this command and wait for queues to drain. So there's nothing in the queues, so everything is good. Now I'm going to delete the replicate. I'm going to start the replication. So I deleted the replicate definition, and now I can rename the table. I'm going to use the rename command to switch between old and new tables. Now we're going to rename the user table to the user table underscore old, and rename user table new to the user table. Now we can restart the applications. Okay. Now the applications are using the new table now. So the new table status, we see applications are actively making changes on the new table. Now you can see that with minimal downtime, we change the fragmentation strategy of a larger table. Uh, by the way, these demo scripts are available on GitHub. This is the GitHub link, and this is the repository for loopback replication scripts. There is a presentation here, PDF file. You can take a look at it as more details on loopback replication. Thanks for your time.